kiddos. Let's do a quick review of what we already know about multiplication. Then we're going to go over one of those problems from our math test. Remember the one with the horse in the corral and the paddock there? We're going to go over that problem together. And then, if you're brave enough, if you think you can handle it, I'm going to show you another multiplication calculation trick that's going to take your skills to the next level. I mean, don't tell anybody. It might be kind of grade 5, grade 6 work, but I know you can handle it. I know you're ready for it. So, if you're brave, stay with me in this video. All right, what we already know. So when it comes to multiplication, let's say something like 3 times 6, we can look at that as repeated addition. So it's 3 sixes. 6 plus 6 plus 6, and that equals 18. Of course, it could also be 6 threes. So we could look at this as 6 threes. 3 plus 3 plus 3 plus 3 plus 3 plus 3. Still ending up with 18, because in multiplication, it doesn't matter which way we look at the factors. Each one of these is a factor. It doesn't matter in which order we go. So let's continue here. Another type of multiplication situation or a way of solving a multiplication problem is we might have groups. So here we can have 3 groups, and there are 6 in each group. So 3 groups, 6 in each group. That gives us 18. This happens to be groups of basketballs. Maybe they're bags in the gym with basketballs in them. Okay, our gym bags there. It could be kids on a team. We could have 6 students on each basketball team. Or it could be girls in the dance class or boys in the dance class. So there's 6 in each class. There's 3 classes. There's 18 altogether, and so on. Continuing on, we can look at multiplication as a number line, right? We have 3 jumps of 6. So 6, 12, and 18. Then, of course, we have arrays, and we've been looking at arrays a fair amount lately. Here we have an array where we have 3 rows. 1, 2, 3 rows. And of course, we have 1, 2, 3, 4, 5, 6 in each row. So 3 times 6, again, there would be 18 dots in that array. Whether it's chairs in rows or a marching band, who knows? But there's a multiplication situation where that array would be the best way to handle that. Now, taking a look at area, this is where we've just finished up our last unit. We can look at multiplication as an area or an area situation here, where we have, like an array, 6 squares in a row, and we happen to have 3 rows. So we have a rectangle here, and if we're doing length and width, it would have a length of 6 units, a width of 3 units, and we can just simply use multiplication. 6 times 3 would be 18, or 3 times 6 would be 18. We don't have to count every single square in that rectangle to know that the area is 18. So it saves us a little bit of time using multiplication. Multiplication is just a quick way of doing addition. It's more efficient and it saves us time. So now let's look at that multiplication problem that we kind of found challenging on the test. A lot of students did really well on it. Some struggled a little bit with it. Let's go over it together so we can see exactly how to solve that problem. Take a look at this question that we had on our test the other day. Let's read it together, and then we will talk about what we can do to solve the problem. Farmer Robin needs to design a paddock that has an area of 48 meters squared. She will then need to build a fence around the perimeter of her paddock at a cost of $23 per meter. Design and draw Farmer Robin's new paddock and work out the cost of putting a fence around it. Record all your thinking. Now, I might have to read that a couple times, and there's one word in here that might be a little confusing. That's paddock. Another word for paddock might be corral or a pen, and you might be able to kind of pick that up when you're talking about building a fence around it. So you know it's sort of an area that is used for these animals. And then, of course, there's a picture of a horse there, so that might also give you an idea that the farmer is building a fence around some space for an animal. After that, it's just a matter of finding the math important information. There's a story being told here, just like the stories we always read. There's a character, Farmer Robin. There's a setting on the farm, and there's a problem. She wants to build this fence. The only difference from a normal story is that we have to help her solve the problem. So Farmer Robin doesn't really matter. It could be Farmer Robin or Farmer Peyton or Farmer Manuela or Farmer Karsten, or it doesn't matter who the farmer is. It's not really math important. It's not even really that important that it's a paddock. These are just words that help us picture or visualize what's happening in this problem. What is math important is this right here. It has an area of 48 meters squared. Those are math words. That's math language. That's important. So we're going to make sure that we understand that the 48 meters squared is an area that's important. She will then need to build a fence around perimeter. Well, math word. There's something important here with that perimeter. She wants to put a fence around it. Doesn't matter what she puts around it. She could drive around it. She could put, I don't know, pylons around it. But here she's going to put a fence around it. So we need to know what that perimeter is. And the fence is going to cost $23. That's obviously important math information as well. We have to design and then find out how much the cost of the fence is going to be. So it's always a good idea to take a little jot note. And here's our jot note. Of the information we have, what we know that the area must be 48 square units. It says right in the problem that it's 48 square units. The fencing's $23 per meter. We know that. Okay, well, what do we need to do? Well, we need to find the area, and we need to, find the perimeter, and we need to find the total cost of the fencing. So once we have what we know and what we need to do, we can get to work, right? So let's take a look at finding the perimeter. Well, what do we have to do to find the perimeter? Well, first of all, we have to figure out what rectangle would work or would give us a 48 square units inside. Okay, and you could do this a number of ways. You could just start coloring 48 squares or however you did it on the test. But because I know multiplication, my multiplication, I can quickly think of 6 times 8 being 48. So it's a really good idea to use your multiplication tables, if you can, to help you solve the problem. So this isn't the only solution. 6 times 8 isn't the only thing or the only rectangle that would give us a unit, 48 square units on the inside for area. We could also use, and some students did, 12 by 4. Because 12 and 12 is 24, and 24 and 24 is 48. Double it when we're multiplying by 4. So 12 by 4 would also work. We could do a 2 by 24 rectangle. That wouldn't really make a lot of sense for the horses to only have a 2 meter wide pen in which to run around in. So I'm not sure that would make sense for the problem. The one that makes the most sense is to use this one that's pretty close to a square, a 6 by 8. And if we are using this 6 by 8, that's giving us a 48 square units on the inside, so I know I'm clicking off that condition. So now I need to find the perimeter. Finding the perimeter, easy enough. Add up all the lengths of the sides. 8 plus 8 plus 6 plus 6. Now I, in my math brain, decided to put the 8s together. That makes 16. Put the 6s together, that makes a 12. You could add straight across. However it works for you, it doesn't really matter. Whatever your strategy is, as long as it works, we're good. So I put the 6 and the 12 together, and then I saw that I just put 16. I'm going to add on the 10s. 16 plus 10 is 26. Add on the 2s. That's 28 meters. Awesome. I found the perimeter of 28 meters. If I have a perimeter of 28 meters, though, and each meter costs me $23, I have a little work to do to find out how much it's going to cost for me to put the fencing around. Now, 28 times 23. Whoa! What am I going to do? That's huge. I don't have my times tables memorized to 28 times 23. Nobody in the world does that I know of. So what am I going to do? How am I going to figure this out? Well, I'm going to go right back to what I know about multiplication. I could do something like, I think Karsten used this strategy. He could literally add 28 23s together. So 23 plus 23 plus 23 plus 23 plus 23 plus 23 and do it 28 times. That's a good strategy, Karsten, and it works. But I'm wondering if there's not more of a more efficient strategy to use. I mean, groups, 28 jumps of 23 might be tough using a number line. How about if we go back to that distributive property we talked about and we look at this 28 by 23 rectangle and we break it down into smaller rectangles that are easier to calculate. Okay, let's hop over to my grid paper and we'll check out how we can solve this problem using our area model of multiplication. Grid paper, it's a little bit smaller, but it has these nice dark lines every 5 units. That's going to make things a little bit easier for us to count. So what I want to do is simply create a rectangle that has a length of 28 units. So 5, 10, 15, 20, 25, 26, 27, 28. So there's 28 units. And again, because of those nice dark lines, I can count by fives. 5, 10, 15, 20, 25, 26, 27, 28. And we know that the width of this rectangle is 5, 10, 15, 20, 21, 22, 23. Okay? So that's the multiplication sentence that I have to solve. 28 times 23. There we go. Well, how am I going to do this? I mean, that's pretty tough. There's a lot of space here with this 28. Let me just put the measurement on there. And by 23 rectangle. Well, let's break it into small rectangles or squares. As you can see, I could count by these groups of 5 here. So this would be a 5 by 5 rectangle or square. Square is a fancy kind of rectangle. So there would be 5 by 5, that'd be 25 squares in that section, 25 squares in that section, 25 squares in that section, 25 squares in that, and so on. However, I like dealing with tens. Tens are friendly numbers. So why don't we just go ahead and use tens? So take a look. 5, 10. So if I were to take that and cut that big rectangle and make it a 10 by 23 unit and do another one here. Let's come over here. Let's make another rectangle in here that is 10 units wide. And then finally now I have something with 8 units over here. But if this, let's just take a look at this rectangle right here. These are identical rectangles. I've got 10 units by 23 units. And what do we do when we multiply by 10? 23 times 10 equals, well, we just add a 0 to the number we're multiplying 10 by, right? So that would be 23 and put on the 0. So I know this section, just this rectangle right here, is 230 units. So that would be the exact same thing over here. It's a 25 by 10, smaller rectangle inside the bigger rectangle, which would give me 230. Now I have to deal with this section over here. And I can do it with a number of different ways. But because I like working with tens, I could do 5, 10 this way. I could make a 10 rectangle right here. And that would leave me with another 10 rectangle right here. So let's deal with these ones first. 1, 2, 3, 4, 5. So this would be a 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 5 by 10 rectangle. And of course, 5 times 10 is, you got it, 50. And this one's identical. So this would also be 5 times 10 equals 50. Now we just have these little ones left over. So I'm going to keep this simple. Kind of draw that across there. I already know that this is 1, 2, 3, 4, 5 across. 5 is easy to multiply by. So this is a 5 times 3 rectangle. 5 times 3 is, quick, come on Macy. Yep, 15, very good. And then I'm just dealing with this whole big rectangle right here. This is a 23 by 3 rectangle. If I didn't want to do 23 by 3, I could break it up and make it a little bit smaller. I could go 5, 10 here. Keep it simple. So this would be a 3 by 10 rectangle, which would be, that's right, 30. And I could do another one here. Now this isn't the only way to break this rectangle up. This is just one I'm just kind of showing you. This is what I see when I start dividing it up into smaller units. You might see something totally different. And down here we have left over a 3 by 3. So of course that would be 3 times 3, and that would equal to 9. Now, I've found the areas of all these different little rectangles inside the big rectangle, so how do I find the area of the entire rectangle? Well, just add these together. So adding all the areas of these little rectangles together, 230 plus 230 plus 50 plus 50 plus 15 plus 30 plus 30 plus 9, we add those all together using any strategy you want to use, and we come up with a total of 644. Remember, there's many different ways of doing it. Do it whichever way is easiest for you. But if the rectangle here is 28 units long and 23 units wide, what I can do is just look for tens. And I really want to focus on the tens when I'm dividing this big rectangle up this time. So 5, 10, 15, 20. I can get a 20 out of here. And I can get 20 going down, 5, 10, 15, 20. So I don't want to stop at 10. I'm going to use the largest tens I can find. So I would have a 20 by 20 rectangle. Okay, so 5, 10, 15, 20 across, and 5, 10, 15, 20 down. So that would leave me with a rectangle of 20 by 20. And what's 20 times 20? Well, let's look at the zeros again. We're going to do our shortcut. We understand what multiplying by tens means. We can just multiply the numbers together and add that 0. So I can take that 0 and that 0. I can actually just put the 2 zeros on and then just add or multiply 2 times 2. So 2 times 2 is 4, and I have the 2 zeros from the tens. Boom, boom. There we go. So without counting, man, can you imagine if I had to count 1, 2, 3, 4, 5, 6, 7, 8, 9 times? Blah! Now, let's do it the easy, most efficient way and use our tens. So 20 times 20, 400. I can do the same thing over here. Let me just extend this line because I know that leaves me with a rectangle that is 20 units long, 20 times, and now how wide is it? Well, it's 5, 6, 7, 8, 20 by 8. And we can use that exact same multiplying by 10 rule where we just use that 0 and put it on the end. So I multiply the other two numbers together. So the 2 and the 8, that gives me, what's 2 times 8? That's just a double. 8 and 8 is 16. And then take that 100 0 over there, placeholder, and we'll put it on the end. So this unit is now, or this rectangle is now 160. Well, what about down here? Can we find a 10 in this area? Sure we can. 5, 10, 15, 20. So we're just going to extend that line down there. And we know that this is 20 units long and 1, 2, 3 units wide. So 20 times 3, again, we can just do 3 times 2 is 6. That's correct. Thank you very much, Jackson. And don't forget the 0 from that 10. Man, friendly tens. I just love them. Our number system being based on 10 is absolutely genius. Anyways, let's take a look now at our final little rectangle. I can't find a 10 here. I'm simply going to have to do my math. But because I have my multiplication tables memorized, this little rectangle won't be any problem at all. I just have to check the length and the width. 1, 2, 3, 4, 5, 6, 7, 8 units wide by 3 units. Now, what's 8 times 3, Zoe? Whoa, that was fast. 8 times 3? 24. All right, now, finding the total area now for that rectangle, just add up all of these products. 400 plus, hey, I got the plus sign right that time, plus 160. I always like to kind of list them from largest to smallest when I can. So I'll do the 60 next, plus 60, and finally, plus 24. Now this also makes it a lot easier for just doing our mental math because I can take the 400, put it with that 100, that's 500, 560, and I can do 60 more, 560, 570, 580, 590, 600, 610, 620. Yes, I was using my fingers, that's okay. 620, and 20 more, 640, and 644. And you can check that with a calculator. Now this rectangle looks kind of nice. It's divided up really nicely. I've used those tens. And this is going to lead us into that trick I was telling you about. Now watch this if you dare. Can you handle it? Are you ready for it? Are you ready to do double digit, maybe even triple digit multiplication in grade 3? I know you are. Let's do it. Over and start doing that whole cool thing I'm going to show you today about multiplying these two-digit numbers together. Let's just finish off our problem from the math test. So 28 times 23, we now have this model that we could use where we broke that big rectangle into smaller rectangles using those friendly tens, made it a lot easier to add that together, and we came up with the total of being 644. So 28 times 23 is 644. But I'm not done yet, Ashton. Remember, we keep talking about make sure you show all your thinking. Well, I think I've shown all my thinking here. Here's my thinking about how I can break the problem down. Here's my thinking about the size of this pen. Here's my thinking about finding the perimeter. I'm using pictures, I'm using numbers, I'm even using words down here to make sure that you understand how I solved the problem, that everything was done properly, and that I've completed this problem to the best of my ability. Okay? So finally, at the very end, when I've done all the work and I've shown my thinking, the very last thing to do is make sure that we answer the question. The question says, draw Farmer Robin's new paddock. We've done that. And work out the cost of putting a fence around it. And we've done that. And I'm going to answer with my words just to finish this problem up. The cost of putting up fencing all around this paddock would be $644. And that's the end of the problem. Now, for all of you who have the nerve, who are ready for some cool learning, let's take a look at this trick that we can use. Not a trick, a strategy that we can use for multiplying double-digit numbers together. We could probably do it faster than your parents. We can probably do it faster than your brothers and sisters, more efficiently, and it's a really cool method. So let's take a look at that. Now, if you're not interested, that's okay, I understand. If you want to just go on and do the first sheet attached to our assignment today, that's up to you. But for the rest of you, let's take a look at this cool strategy. Check this out. This is what I like to call the super cool box method of multiplication. Now, to do this, there's only one thing you really need to be remembering. Way back in September, October, we talked about how we expand numbers. So what does the expanded form of a number look like? A little review, and I'm sure you'll remember right away. So if we're looking at 28, what's 28 in expanded form? Well, 28 is 20 plus 8. That's 28 in expanded form. What about 23? Well, it looks very similar. 23 in expanded form is 20 plus 3. Now for the box method, all you need is a box. And because we're doing 2-digit by 2-digit, our box has these 4 sections in it. We put the expanded form of 28 on one side, and it doesn't matter which side, but for this one I put it on the top, 20 and 8. The expanded form for 23, 20, and 3. So when we're done, we're going to find out what the product of 28 times 23 is. Look how easy this is. It's so cool. First, we just treat this like a multiplication table. 20 times 20. Well, let me just click in the box here. It looks a little funny, but I'm just going to type in 20 times 20 equals. Now, what's 20 times 20? Well, when we're dealing with tens, we just keep those zeros. We multiply the other numbers. So 2 times 2 is 4. 4. And then we have the 2 10 zeros. Let's put those 2 10 zeros back on there, those placeholders. So 20 times 20 is 400. We do the same thing over here now. We do 8 times 20. So 20 times 8 equals, well, there's 1 0 for the 10. Let's multiply the other 2 digits. 2 times 8 is 16. That's the double. And then the 0 for the 10. So easy. All right, let's check this out. 20 times 3. Okay, so 20 times 3 equals, There's the 0 for the 10. 2 times 3 is 6. Put on that 0 for the 10. 20 times 3 is 60. And finally, 8 times 3. Well, 8 times 3 is 24. There we go. So we filled in our boxes. Now, all we have to do is add these products together to find the answer to 28 times 23. And it looks something like this. 400 plus 160 plus 60 plus 24 is, well, let's try that mental math again. 400 plus another 100 is 500 plus 60, 560 plus another 60, 620 plus 20, 640 and 4, 644. That's the exact same calculation we got when we were looking at our area model. So that is a really cool way to multiply using two-digit numbers. Let's try another example. With the super cool box method of multiplication, problem number 2. Here we have 16 times 35. Thinking back to September, October, we need to understand what expanded form looks like. And if we're looking at the expanded form for 16, that would simply be 10 and 6. 10 plus 6, 16. And for 35, it would be 30 and 5. So putting them into our table here, we have 10 and the 6 for the 16, the 30 and the 5 for the 35. 30 times 10, using it like a multiplication table where we multiply the numbers that are across from each other and up and down. So 30 times 10, we have the two 10 zeros. So I'm going to have 2 zeros for those 10s on this one. 3 times 1 is 3, and then the 2 zeros for the 10s. Here we have 30 times 6. Again, the 30 from that row and the 6 from that column. 30 times 6. Well, 6 times 3 is 18. And then don't forget the 0 for the 10. Here we have 5 times 10 is equal to, well, that would be 50, even if I had to go 5, 10, 15, 20, or sorry, 10, 20, 30, 40, 50. And last but not least, we have 6 times 5, and that, of course, is 30. Now, adding these products together, this time, why don't we use the stacked method? There we go. And we'll see what we come up with here. 0 plus 0 plus 0 plus 0 is, that's an easy one, that is 0. 0 plus 8 plus 5 plus 3, well, I know 5 and 3 is 8. That gives me an easy double here. So I can do 8 and 8 is 16. So I'm going to put the 6, carry the 1 for the 16. 3 plus 1 is 4, plus 1 more is 5. Pop in the 5 down here. And we have the final product of 560. So 16 times 35 is 560. Check it out on the calculator if you don't believe me, but the box method never lies. Example, switched it up a little bit on you. 346 times 6. So here we're multiplying a 3-digit number by a 1-digit number. Doesn't really change too much, just makes our boxes look a little bit different. So now, when we talk about expanded form, we can see that we have 300 plus 40 plus 6, this expanded form for 346. And then 6, well, you can't really expand 6, it's just 6. Putting it onto our table, 300, 40, and 6 times 6. So use it just like our multiplication tables. You do the 300 times 6 first. 300 times 6 equals. Now, we haven't talked about multiplying by hundreds yet. This is a little bit new, but nothing really changes here. We just take the 2 zeros from those hundreds. We're going to put it on the end of the number after we multiply these digits together. So we do 6 times 3 is 18, and then add on the 2 zeros. So 6 times 3, 18, add on the 2 zeros. That easy. 40 times 6, well, 40 times 6. 4 times 6, this is multiplying by 10, so we're going to hold that 0. 4 times 6 is 24, so 6 and 6 is 12. 12 and 12 is 24. We can double it. 24, and then there's the 0 from that 10. And finally, 6 times 6 is equal to, that's one of the ones that rhymes, we kind of like that one, 6 times 6 is 36. Now, to finish that off, add those products together. We have 1,800 or 1,800 plus 240 plus 36. Using my mental math, I can do 1,800 plus 200. Well, that's 2,000. So let me put a 2 in the 1,000 spot. 2,000, and then let's look at the hundreds. Well, we've used those up. The tens, 40 and 30 is 70. So we put a 7 in the 10 spot. And finally, 0 ones, 0 ones, and 6 ones would give us a number of 2,076. 1,800 plus 200 is 2,000. No hundreds left over. 40, 70, and 6. 2,076. And again, you could stack those and add them any way you wanted. Now, for today's work, your practice, I'm going to challenge you to try and solve some problems using this cool box method. Look at the attachment. You don't have to. This is just totally for fun today. I know this video is long. You've done a lot of watching. You've done a lot of listening. Do a little bit of practice. You can choose just to do the regular multiplication sheet, or you can choose this more challenging box method. Give it a try. It's really cool. And once you know how to do it, it really makes those multiplications of double-digit, triple-digit numbers a lot easier and really quite fun to do. So give it a go. Have fun with math today.